submit it to it, man.
I'll sign my name on it too.
All right.
Okay. Turkey. Dookie. Dookie.
Come on, we're not gonna take all the time on this. We've got other stuff to do. Let's go.
I thought you were doing all of them.
No, come up and do one. I mean, you need to be able to do all of them, but just come up and do one. Let's go.
Come on, Mike.
No.
Signing our names.
Not a problem.
Royce, do you want to do one?
Love that. I mean,
Positive feeling. A lot of fun.
Let's go.
Royce, come on.
This is better. This is Mark's quiz. Thank you, Harper.
Yeah, I'll sit down.
I don't.
No, sit down. We're gonna get some of these other people up here.
Braden? Royce?
Oh wait, I have another one.
What did you know
That
about?
is a 3-year-old.
So far, everybody's been perfect. Oh, so we just need people.
Or no?
Hey, Tarby.
This should be a negative. Sorry.
Can I do a second one or no?
Well, we're gonna see what people
Well, we want to do faces, Jimmy.
Okay.
Royce is going up next.
Alright. This is coming.
I think Royce.
This Ben's coming now. And girls, so far, Harper's been the only one. Come on.
Yeah, you need some.
Represent us.
Let's go, Harper.
You didn't even know.
It's not bad.
We're still at 100%, guys. We're so awesome.
Braden, you cannot say words with your problem. What?
You might not be able to see Royce's answer because it's behind the TV. He said this was his answer.
That is correct.
I like that word.
That's not correct.
Would it be -1?
It'd be -1. Because what happens at 0, guys? At 0, we
It splits to
have
-1.
a point. And when you have a point at your X value, listen, when you have a point, at least he tried, that's more than the rest of it did. When you have a point at your X value, the limit is Y. And Y here is -1. That should be -1. And then what about this one? As we approach our asymptote, from the right side, what's happening? Okay, tomorrow you gotta be able to do that, folks.
Proud of it all. It's all good.
Royce, that's the way that's Braden. That should not happen.
Okay, next problem, back in our notes, here we go, it's a big one. Wanted to teach kindergarten. That's your IP. So I started, this is just like the last one, I started by factoring this denominator, is that okay with everybody? Took out an X. So X plus 2. And then especially after what happened last time, I'm gonna make a list up here. X cannot be 0. And X cannot be -2. In case you are ever asked, those are called excluded values. Excluded values. Okay? Now, I need every denominator to be the same. So this one is gonna need an x plus 2. This one is gonna need an x. And that one doesn't need anything. Right? Once you have done that, then you can lose the denominators. You don't need the denominators anymore. And you have just the numerators with the signs plus 3x plus 6. Is that all right with everybody? All right, let's do it. This one I have left. So I can take out an x. And x equals 0 or negative 2.
What? Oh, that's, can't be any of them.
Can be any of those. So the answer to this problem is no solution. We did all of that work and did not come up with an answer. Okay? Now we have some word problems. Now, I know at some point in your life, you've done this word problems like this before. But I don't know what your approach was when you did it. So I'm gonna share with you how I do these problems, and then you can do it however you want, so long as you end up with the same answer. But remember when we did those mixture problems, and I gave you a little formula, amount times percent, plus amount times percent equals amount times percent, and that format would work with all the mixture problems. Well, with these problems, when you've got 2 or more people doing a job together, the formula that can be used is 1 over alone plus 1 over alone equals 1 over together. So what that means is, in this problem, Jessica can paint a room in 5 hours. So Jessica's time alone is 5 hours. Brenda takes 6 hours. So her time alone, I'm gonna put 1 over 6. And then that equals 1 over their time together, which is what I'm looking for. How long does it take them to do the job together? And now you can see why this problem is in this section. We're going to make all the denominators match, and we're going to solve it. So what will all the denominators have to have if they're going to match?
30.
They got to have a 30, and they got to have an x. So this one needs a 6x. This one needs a 5x. And this one needs a 30. And as soon as you've done that, then 6x plus 5x equals 30. Numerators, numbers multiplication. So 11x equals 30, and x equals 30/11 hours. Easy enough? All right, let's look at the next one because it has a little bit of a twist. We have 2 hoses running into the pool. But unfortunately, unfortunately, somebody left the drain open. So the two hoses are putting water in and the drain is letting water out. But the same format can be used. What is hose X's time alone? How long does it take hose X to fill the pool? 10 hours, so 1/10. There's hose X. What about hose Y? 1/4. Now, what about the drain? How long does it take the drain to empty the pool? I don't know how long it takes the drain to empty the pool. But I know that it takes 15 hours to get it full. With 2 running in and 1 running out, does that make sense to you that that would be a minus, not a plus? Because it's working against the other 2. If 3 hoses were going in, it would be plus, plus, plus. If the drain is open, so that's a minus. And I do not know, how long does it take the drain to empty the pool? That's what I'm looking for. All right? Okay. What's my common denominator? 60. There are lots of common denominators. That's the smallest
60
one.
X.
Your job is to find the common denominator. If you use 60x, this needs a 6x. This needs a 15x. This needs a 60. And this needs a 4x. Now there is no magic there, you guys. You just want to make every denominator the same. So are they now the same? So then I can just look at the numerators. 6x plus 15x minus 60 equals 4x. So 21x minus 60 equals 4x. Negative 60 equals negative 17x. And x equals 60 17ths hours. So it's going to take the drain. What is that? A little bit less than 4 hours. So when you have things working together on a project, overwhelm plus 1/1 equals 1/2. This one was a minus because he wasn't helping, he was taking both the other direction. All good? Perfect. Breaking even. Here we go. This is a different kind of problem. This is not that kind of problem. I'm not sure what it is. Alright, let's start. I'm going to kind of forget that A, B, and C step for a second. And let's start by seeing if we can come up with come up with a way of finding profit. What is profit by definition? What's profit? Not in terms of this problem, but just in general, how do you get profit? You make more than you spend. So it's income minus expenses. You make more, you have more income than you have expenses. Would everybody agree with that? I hope so. Okay. Now, needs to sell golf hats for $275 each. So what is my income going to be? If I have X hats, what will my income be if I am selling them for $275 each? What if I sell one hat? How much does I make?
275X.
275X, thank you, Jimmy. 275X, that's my income. Every X brings me in $2.75. Now, what are my expenses? Each one costs $212. Would you agree with that? But there's even more expenses than that. That's the cost of producing a hat. That doesn't include your weekly overhead of $3,000. So your income is not just the cost per hat, but also your light bill, your rent, your gas bill, your telephone bill, whatever, all the overhead that goes into running the place. So let's clean that up. 275 minus 12 minus. So what's that? Is that 63? Bigger than 0. So 0.63x has to be bigger than 3,000. And x has to be bigger than whatever 3,000 divided by 0.63 is. Looks like to make a profit, I have to sell 4,762 hats. What happens if I sell less than that many hats? I lose money, right? This is like my break-even point. I gotta sell that many or more to make a profit. How many golf hats, this is a receipt, how many golf hats must be sold to make a profit of $1,000? How would I do that? I want to make a profit of $1,000.
1,000, just change it down. Set it to 1,000.
Set 0.63x minus 3,000 equal to 1,000. So 6,350 hats. 4 into this equation, that would tell you how many bears you have in the 4th year. All right? So the question says, find the population of bears in 10 years, 40 years, and 100 years. All right, let's do that. We're going to our calculator. 10, 40, and 100. And let's just round it off to the nearest bear. We don't want to have fractional bears. So put in 10 for the t's, work it out, and see how many bears you get. Anybody get 200 for 10 years? Anyone get 350 for 40 years? And 425 for 100 years? It looks like as I go longer and longer in time, my population is growing. The second part of that question says, if I graph that equation, would it have a horizontal asymptote?
Yes.
I heard yes. What is it?
I don't know. I can tell it.
You know it has a horizontal asymptote. When an equation looks like this, where is the horizontal asymptote? This, where's the horizontal asymptote? Horizontal asymptote is y equals 2 because of 2x over x. Let's look at this one. T over t. Isn't this going to be the horizontal asymptote? What's 250 divided by 0.5? 500. The horizontal asymptote is 500. What does that mean in this problem? Exactly. The maximum population is 500. Why would that be? Do you know? Can population just keep growing and growing and growing? What happens? You run out of space? You run out of food? Right? Every year there is a controlled deer hunt in Fort Benjamin Harrison. Why do they do that? Why do they let hunters go into the state park and shoot deer?
There's not too many.
Because they get too many of them and they start starving to death, they get sick, there's disease that runs rampant through there because the population can't just keep going. Right? You've heard of animals eating their young. That's a kind of tricky thought, but it's because there isn't space for that. Maximum population 500. All right, one more. Let's get her started. We might not be able to get it done. Number 9. The total resistance is given by yes. Do not let all the R's confuse you. They are different variables. So if you want to give them different names, you can. wanna call this one X and this one Y, you absolutely get it. These are three different variables. One resistor has a resistance of 2.3. The other one has a resistance of X. Solve that equation right here. No. One way to solve it, we need to make all the denominators the same. What would they have to do? They have to have an R, a 2.3, and an X. So this one is a 2.3X. This one needs an R and an X. And this one needs an R and a 2.3. Are all of the denominators now the same?
Yeah.
So 2.3X equals Rx plus 2.3R. 2.3X, Rx, 2.3R. We're solving for R. So let's factor it out. Right over here, my two R's are on the same side. I'll factor them out. And then, so the answer to part A is right there. And then we will do part B tomorrow, because unfortunately our time has expired. I'm not assigning 2.7 just yet, we have 1.5 problems to go, but certainly if you want to get a start on it, you can.